Sextant. Basic Structure and Error Finding. By Vishal V. Vastu.
This is the sextant architecture, or you can say the labeling of sextant.
What is the marine sextant? What does it measure? The sextant is an instrument used to measure angles. Its arc is 1/6 of a circle, hence it is called a sextant. In actual practice, the arc of the sextant is about 65 degrees. Being an instrument of double reflection, it can thus measure angles up to about 130 degrees. Measurements by a sextant. 1. Altitudes of celestial bodies. 2. Vertical angles called vertical sextant angles, VSA, of terrestrial objects. 3. Horizontal angles called horizontal sextant angles, HSA, between terrestrial objects. Mechanical and optical components. Mechanical components. A frame fitted with a brass arc AC over image and arm, called the index bar, pivoted at the geometric center of the arc. A spring-loaded disengaging clamp for large movements of the index bar. 3 legs on the underside for supporting the sextant when placed on a table. Handle for holding the sextant during use. Optical components. A plane mirror, called the index mirror, fixed on the index bar centered over the pivot. The index mirror is fitted perpendicular to the plane of the frame and the arc, called the plane of the sextant. Horizon glass also fitted perpendicular to the plane of the sextant. Half the horizon glass, closer to the frame, is silvered to become a plane mirror. The other half is plain, transparent glass. When the index bar is set at 00 degree and the micrometer at 00.0, the index mirror and the horizon glass should be perfectly parallel to each other. A telescope, fitted in a collar, so that the emergent ray passes through the telescope onto the observer's eye. The axis of the telescope is parallel to the plane of the sextant. A control knob, with a milled head, controls the distance between the axis of the telescope and the plane of the sextant. This distance should be such that when looking through the telescope, the mirror glass separation of the horizon glass should appear in the center of the eyepiece. 2 sets of colored shades, S1, for the index mirror, and S2, for the horizon glass, with individual shades of differing shade densities, for use when the body or the horizon is too bright. Minimum number of shades should be used. Better to use one dark shade than 2 lighter ones in combination, to minimize possible shade error, which is explained later in this lesson. Components for measurement. A brass arc, with full degree graduations engraved on it. A micrometer for precise control of the index bar. Vernier that enables you to read angles to 0.1 minute, or to 10 seconds. Of arc in rare cases. Figure 2a shows the enlarged views of the front of a micrometer, wherein you can see the micrometer drum and the vernier scale. One full rotation of the micrometer spindle causes the index bar to move by 10 on the arc. Fractions of a degree and can be read off the drum of the micrometer, which is divided into 60 equal parts, each denoting I of arc. Spring-loaded clamp that disengages worm from rack for quick movement of the index bar over large angles. Figure 2b shows the enlarged views of the rear of a micrometer, wherein you can see a continuous thread rack attached to the rear of the arc. A worm that engages into the threads of the rack. How to read sextant altitude. The accompanying picture shows the arc, micrometer drum and vernier scale after you have made an observation. The index mark is between 29 degree and 30 degree. So, the full degree reading is 29 degree. The 0 of the vernier is between 42 and 43 on the drum. So, the full minutes of the reading are 42. The 5th mark of the vernier scale coincides exactly with the mark on the micrometer drum. So, the decimal reading is 0.5. The reading of the sextant is, therefore, 29 degree 42.5. Explain what are readings on the arc and off the arc. The normal graduations of the arc, to the left of 0, extending from 00 degree to 130 degree, are referred to as on the arc. To the right of 00 degree, the graduations extend for few degrees and are referred to as off the arc. The arc indicates full degrees, the micrometer indicates full minutes of arc, and the vernier indicates fractions of a minute, either in steps of 0.1 minute of arc in modern sextants, or 10 seconds in old ones. Figure 3a. This diagram shows the sextant when the reading equals 0 degree 00.0. Notice that the index mark is directly under the 0 degree marked on the arc. This means that the reading in degrees is 0. Then note that the 0 mark on the vernier scale is in line with the 0 mark on micrometer drum. This indicates that the reading in minutes is 0.0. So, the full reading of the sextant is 0 degree 00.0. Notice that the index mark is directly under the 0 degree marked on the arc. This means that the reading in degrees is 0. Then note that the 0 of the vernier scale is about halfway between 0 and 1 on the micrometer drum, indicating that the reading is approximately 0.5 minutes on the arc. Then note that the fourth mark on the vernier scale is the only one that coincides with the mark on the micrometer drum. This indicates that the accurate reading of the vernier scale is 0.4. So, the full reading of the sextant is 0 degree 00.4 on the arc. Notice that the index mark is directly under the 0 degree marked on the arc. This means that the reading in degrees is 0. Then note that the reading is off the arc, indicated by the fact that the 0 of the vernier scale is on the wrong side of 0 on the micrometer drum, and that the value, as per the micrometer reading, is approximately 0.2 off the arc. Then note that the 7th mark on the vernier scale is the only one that coincides with the mark on the micrometer drum. This indicates that the accurate reading of the vernier scale would have been 0.7 if on the arc, but since the reading is off the arc, you should read the 7th mark as 3.1 from the other end of the vernier scale. The vernier scale reading is thus 0.3 off the arc. So, the full reading of the sextant is 0.000.3 off the arc.